the chain rule. Objectives. By the end of this lesson, you should be able to recognize when to use the chain rule, apply the chain rule to find a derivative function. So first of all, chain rule is probably the most important rule, law, whatever. It's probably the most important section of derivatives. You have to know how to take the derivative chain rule. It shows up everywhere. Almost every derivative we can do from here on out is some part of a chain rule. It's implied to everything. It's never going to go away. When we get to next semester, when we start doing more stuff with calculus, integrals, we're still going to do a chain rule. It just never goes away. It always comes back. You have to know how to do it. Luckily, chain rule is also my favorite rule in calc. So, to show my love for it, and let's do a little harder. I can fill that in. We use it so much, and it's so helpful. It's my favorite rule. So let's talk about what the chain rule actually is. So a couple things. Chain rule, if f and g, it has to do with composition of functions. Before I even start talking about that, right? What is it? It has to do with when you have one function side of the other function, right? So f of g of x, g of f. That's what a chain rule has to do with. If you look here, here's a derivative. If you're taking a derivative of functions within a function, this part actually kind of helps. It's the derivative of the outside. Notice how they leave the inside alone times by the derivative of the inside. That's what this says too. You have an outside-inside function. It's the derivative of the outside. Leave the inside alone times the derivative of the inside, right? You're like, that's kind of confusing. I'll make it easier in a second. But before I do that, I want to show you what the IB book has. This is your formula sheet. Chain rule equals this. That's a monstrosity. That I have no idea what that tells me, right? So we're not going to be able to use that. You're going to have to memorize it. Now, the thing with this, though, it's actually a lot easier to memorize if I just write it like this. So here's f of, let's say there's some function with the u inside of it, right? So that's my function, f and then u. The derivative is, just in words, is the easiest way to memorize chain rule. So in words, take the derivative of the outside, so f prime, leave the inside alone, so you just leave a u there, and then you times by the derivative of the inside, u prime. That's the chain rule in a nutshell, right? So you take the derivative of the outside, you leave the inside alone, and then you, very important, last step, a lot of people forget the last step, then you times it by derivative of the inside. Times derivative of the inside function. And that's the chain rule. So again, nothing you see here is going to make it making it easy for them to memorize. That thing, I don't even know what they were thinking. The easiest way, the way I've been doing it forever, is in words. I mean, that's how I do all my derivatives, honestly, in words. I just think it makes more sense. So you take the derivative of the outside, you leave the inside alone, and then you times by the derivative of the inside. And that's a chain rule. So the key thing about the chain rule is you have to know what the inside-outside function is, right? So when I say take the derivative of the inside, take the derivative of the outside, leave the inside alone, what does that mean? Well, let's practice it here. So look at this first one, right? The inside function is going to be the x squared. The outside function is sine. Now we haven't learned how to take the derivative of sine yet. That's actually the next couple videos from now. But the inside is x squared. Outside function is sine. Over here, now this one's a tricky one. It's sine squared x. Anytime you see that written like that, they actually mean this. Sine the whole thing squared. So when you see something written like this, like a sine, and especially with trig functions, sine, cosine, cube squared, it's the whole thing is squared. So the inside would be the sine. The outside would be x squared. A lot of times people write, oh, x squared is outside. I just think about it, it's something to the power of x. Outside is x squared. The square is the outside. Look at this one, right? The inside is 2x minus 1. The outside would be the square root of x, or x to the 1/2. Again, for me, the way I think about it, I just rewrite this. 2x minus 1 to the 1/2 power. This is the inside, and then this is the outside, the power thing. Same thing if we move down the line. Right, my inside's going to be the cosine x. That's my inside function. My outside function is a 1/3 power. Right, so this is my inside. This is my outside. Again, most books say outside is 1/3. I don't want you guys to get, a lot of people start adding in the 1/3, adding in the x to it. That you're plugging that into the x, right? So that, yeah, my two functions are cosine x and x to 1/3. But I think it's easy to understand the power. That's kind of the outside function. This one's tricky. The inside is this. If you take that away, what's left over? 1 over x, right? You're plugging x squared minus 1 into this function. So this is your outside function. So your inside function is x squared minus 1. What are you plugging that into? You're plugging that into like a function that's 1 over x. Right, so here's the classic example I'm talking about. So here's your inside. It's a classic chain rule problem. And the outside will be the 7th power, x to the 7th, your outside technically. But you're not ever going to have x to the 7th anymore. You're going to treat the 7th power kind of as the outside function. And then this one, last one of these inside-outside things, e to the x, e is the outside. My outside is e to the x. My inside is a power here. So that's the inside function, is the x squared. Okay, let's actually get to some problems. So like the one we just talked about, let's take the derivative of 2x plus 3. Now remember the chain rule is take the derivative of the outside. So I think for me it's always, when I try to write it short, I'm just write this. I take the derivative of the outside, so f prime. Leave the inside alone, and times by the derivative of the inside. So if I was doing this one, right, my outside is the 7th power thing, so I'm going to take the derivative of the outside, bring the 7 down, subtract 1 off. So it's going to be 7, 6. Then next, I got to leave the inside alone. So 2x minus 3 is 2x plus 3 is going to stay in here, because leave the inside alone. And then the last step, times by the derivative of the inside. My inside is 2x plus 3. The derivative of that would just be 2. And that's my derivative, also known as 14 2x plus 3. It's the 6. Right? That's the way it's going to work. We're going to take the derivative of the outside, whatever the outside function is. We're going to leave the inside alone, and then times by the derivative of the inside. Don't forget to do this part. Don't forget to take times by the derivative of the inside. So, let's do the next one. So again, we never leave radicals in calculus. We always rewrite it. 2x minus 1 to the 1/3, sorry. So now we can know what our outside function is. It's the 1/2 thing. So we do what we always do. Bring it down, subtract 1 off. So I get 1/2, negative 1/2, 1/2 minus 1. Leave the inside alone, and times by the inside. Again, as I always say, you can leave like this. It's like you leave down like that, unless they specifically ask you to. You can simplify it. The 1/2 and the 2 cancel out. I just get 2x minus 1 to the negative 1/2. Or if you prefer, 1 over the square root of 2x minus 1. But again, this is fine unless they specifically say put it in this form. The next one could go one of 2 ways. So if you look at this, my first thought would be quotient rule. And that does work. We could do the quotient rule, so u, that's b, do all that stuff. How does it give me a chain rule? What kind of we talked about before? Actually, if we're going to do a chain rule, we're going to rewrite it like this. Probably the easiest way. So if you don't like the quotient rule, you can always just rewrite it. And now it's a chain rule. Take the derivative of the outside, subtract 1 off. So I'm going to get negative 1. Let's mess that up. Leave negative 1. 1 minus 1 is negative 2. Sorry for this one being so sloppy. Leave the inside alone. And then don't forget, times by the derivative of the inside. Don't forget that, please. A lot of people forget that part. Again, if you want it less messy, not just because I write it bad, you do this and x squared minus 1. But again, unless they specifically ask, you don't have to. Like also, if I want, flip that down. So this is the next couple. E's. Now remember, E's, a couple things with these, right? So that's the outside. Don't forget the derivative of e to the x is e to the x. So when you're doing derivatives of e, honestly, the easiest way to do it is just copy it. Take the derivative of the outside, which is e. Leave the inside alone. So look at, really I just copied it. Then times by the derivative of the inside. So derivative of f of x is f prime of x. And that's it. For me, it's kind of just a rule now. Like anytime I see e to some power, the easiest way to take the derivative is just copy it down and times by the derivative of the inside. That's a shortcut for e. Is just copy it times by the derivative of the inside. So if I was doing this one, the derivative is going to be just copy it, e to the x squared, then times by the derivative of the inside, 2x. Right? If I give you e to the 5x, I'm like, okay, copy it, times by the derivative of the inside. So that's how you take the derivative of e. This next one, notice the chain rule. Right, so take the derivative of the outside, so 7, bring it down, 7, subtract 1 off, right, we're going to bring it down, subtract 1 off. Leave the inside alone. Times by derivative of the inside. Right? Again, they tried to draw the f of x to mess with you. I just think they're easier. They're like, are you kidding me? You trying to mess with me? This next one, another one, right? Now, notice the outside here is the f of x. So take the derivative outside. F prime. Leave the inside alone. 7x. And please don't forget, times by derivative of the inside. 7. Let's look at this next one. Right, so let's do two harder ones. Here, I have 5x squared times 3x squared minus 1. Look what rule that is. Yeah, I'm multiplying. It's a product rule. So I got, remember the product rule? We just did it a little while ago. It's u prime v plus, well, so let's go. So let me try it. If you're multiplying two functions, only if you're multiplying two functions, which I'm doing here, then it's the derivative of the first one times the second, plus switch it, derivative of the second times the first. Right, if you want, you could write each one. Let's do this one. This is a little more difficult, so I'm going to write each one. You don't have to do this, though. Let's say this is u and this is v. U would be 5x squared. U prime would be, bring it down, subtract 1 off, 10x. V is going to be 3x squared minus 1 squared. Now, the whole reason I wanted to write it out, because this one's a little more difficult, is this right here, right? The derivative of v is a chain rule, right? It's this inside something squared. So we do a chain rule, bring it down, subtract 1 off, leave the inside alone, and don't forget the final step, multiply by derivative of the inside. So in this case, that'll be 6x, derivative of negative 1 goes away. So that's my derivative of my inside. Again, if you want, you can simplify it, make it 12x, you can distribute it in, but I'm just going to leave it like that. Right, now I have that, I can plug it all into my formula, which is in your formula sheet. So u, 5x squared, prime, 10x, sorry. U prime, 10x. V left alone, 3x squared minus 1 squared. V prime, this mess. I'm going to combine it a little bit for space. I can simplify more if I wanted to. Times u, and u is 5x squared. Again, you know how to simplify unless it specifically asks you, but that's how you do that, right? It's a product rule that has a chain rule within inside of it. That's all we're going to get now. We're going to get so many chain rules. Everything's going to be a chain rule for the most part. Look at this next one, right? Our last one was a product rule. Look at this. We're dividing. This one's going to be a quotient rule. So I'm going to do the same thing I did before. Here's my u, x. U prime would be 1. V, we got to rewrite it. Remember, we don't like, in calculus, we don't like square roots. Fraction. We like fractions instead. And then v prime, that's a chain rule. Bring the 1 down, subtract 1 off. Times the derivative of the inside, which in this case would just be negative 3, right? The 1 goes away. The derivative of this is just negative 3. So that's my u, my v. I forgot to write the quotient rule. It's in your formula sheet. U over v is derivative of the top times the bottom minus flip it, derivative of the bottom times the top, all over the bottom squared. Right, so if I was going to plug this in, u is 1, how lucky. V is 1 minus 3x to the 1/2, sorry, I almost looked at this. Minus v prime, so I'm going to come out a little bit for space. Negative 3/2, 1 minus 3x to negative 1/2, times v, sorry, times u, which is x, all over the bottom squared. So again, let's say specifically ask you to simplify it, you can leave it like that. You can simplify a little bit, but I mean, like, these cancel out, but nothing much. I'm just gonna leave it like that though. Okay, a little treat for you guys. We haven't talked about how to use our calculators yet. Let's do that now. So let me bring up my calculator here. So let me bring over my calculator over here. Now, again, I expect you to know how to do this by hand, because your calculator only could do stuff when it's like x equals 4, when I give you a value to plug it in. It's the only time a calculator actually do a derivative. If I just give you a problem that said, oh, take the derivative of this, it's not going to be able to help you, right? It only at a value. Calculator can only give you a derivative number answer. So, but let's talk about how to do it. There's actually 2 ways your calculator could do this. Let's talk about the easy way first. So you go to math. We're going to take the derivative, so we're going to go right here under n derivative, number 8. Then we're just going to type it in. So first I want the variable, so x. There we go. And square root x. And then we're going to go, so second square root, what's going on? Second square root x. And then parentheses, x squared minus x plus 1. Close the parenthesis. Now I got a square. Don't forget the square. That's a big part of this. And then now you go over here to x equals. That's why your calculator could do this, right? It's at a value they want. Again, if you leave that blank, you're not going to be able to do anything. So x equals 4. So we're going to find the derivative of this thing at 4. You hit enter, and you get your answer, 406.5. So we get 406.25. So that's the first way of doing it. The other way you have to know how to do also, but usually it's an attachment to another problem, and that is we have to graph it. So you go to y equals, I already typed it in to save you some time, and then we're going to graph this thing. So again, a lot of times the second way is going to be, first part of the problem is graph this function, usually a trig function with some radians. Then graph it, and then the second part will be, like part B would be, oh, find derivative at 4. Well, the way we do this is you put second, calculate, and all these things come up, right? Values, if you want to find what the y value is. Zeros, you want to find the zeros, min and max. Intersection, dy dx, or derivative. So hit number 6. Now right here, you can move your thing around, but the easiest thing to do is just type in what you want derivative of. We want it of 4, so hit 4. See it says x equals 4. We're going to find derivative at 4. Hit enter, and then right here, 406.25. That's our derivative. So 2 ways again to find derivative in your calculator. Let's do this one real quick. So I'm going to go back to the home screen because that's the easiest way of doing it. So I'm going to go to math, number 8. Right, let's put x for a variable. Now remember, if you want to do a fraction, you go alpha y1. F1 would be the easiest, so you make a little fraction button. You can just put divide, but if you put divide, you get parentheses. Very important. If you're going to divide this without the alpha button, parentheses around these two things, so your calculator knows. Otherwise, you can get it wrong. By the way, TI-84 and above should have this like nice, pretty font here. If you have an 83, it's the same idea. It's just you got to remember the pattern, which is formula, variable, then number. If you have some Casio, I have no idea what's going on because Casio is terrible. But anyway, so that right there is going to be square root x. Again, see how much nicer it is if you use the alpha F1 button? It makes it so much easier to put it in. So you're not worried about like putting it in correctly or incorrectly. And then again at 4. Over here to 4. 4 it pauses. There it goes. Hit enter. And then negative 0.021. So that's how you do these with the calculator. So that's how you can do derivatives with your calculator. Almost done here. Let's look at this one. I'm going to show you a classic show that. Remember I said you don't have to simplify unless they say show that. Sometimes it gets a little ugly, but here's an example of this. So let's do this one. So they want to do this thing here. They want to show that the derivative, that's what this means, derivative equals this. So remember, you can't use that. You got to get that as an answer. So just take the derivative. This is my u, this is my v. Let me rewrite it to x to the 1/2 times 3 minus x squared. So if we're going to chain rule this, right? Oof, almost messed that up. Very important. 3 minus x quantity squared. Very big difference. One's a chain rule, one's not. So we're going to do a product rule, right? We're multiplying two things. Take the derivative of the first one. 1/2 x to the negative 1/2, right? Bring 1/2 down, subtract 1 off. Times the second one left alone. Plus derivative of the second, that's a chain rule. Bring the 2 down. Do the inside alone. Times right derivative of the inside, which is negative 1. Times the first one left alone. So x to the 1/2. Alright, so that's the product rule. And I got to make it look like this, and you're like, they don't look alike. Like, kind of not at all. Right, so this is kind of where it helps to kind of go backwards. You're like, wait. Let's separate these two. This is the same thing as saying 1/2 square root of x, 3 minus x, 3 minus 5x. Then you're like, wait, 1/2 is the same thing as x to 1/2 power. Right, this is the same thing as saying 1/2 times x to the negative 1/2 power. I kind of have that right here. So let's get that out of the way. Let's factor that. Now the problem is I can't just move that to the bottom, right? I got to factor it out. So let's factor 1/2 x to 1/2 out. If you remember, you can factor anything out of anything. When you factor, you just got to divide. You divide that side by that. Well, that just goes away. You're left with 3 minus x squared. Factor. Now here's the hard part. You're factoring out of this side. Well, you got to divide by it. So like let's divide that 2 by 1/2. Right? If you divide 2 by 1/2, it's like multiplying by the reciprocal. So you just get 4. I'm going to leave that 3 minus x alone. I'm going to leave that -1 alone. And then I'm factoring out by x to -1/2. Again, factoring is just dividing. So when you divide these two, well, remember you just subtract the powers. 1/2 minus -1/2. That's going to be x to the first. So this is x here. So now if I want to make it look like that, just kind of got to simplify this thing. I mean, let's kind of work on this. This is a mess. -x times 4 is -4x. 3 minus x. So if I distribute, I'm going to get -12x plus 4x squared. So plus 4x squared. This, you got to expand. Remember, don't just give me 9 minus x squared. That's wrong. 3 minus x times 3 minus x. If I do that correctly, I should get 9 minus 6x plus x squared. Remember, this all has this in front of it. So like it's kind of like this. Which I'll move to the bottom anyway. So that's going to go to the bottom. It's going to be like, on the bottom it's going to be 2x squared of x. Now all this, it's add up like terms. You get 5x squared. -6 minus 12 is -18x. And then plus 9. And that factors, I'm pretty sure it factors to that. So 3 minus x, 3 minus 5x. Right? It's a lot of algebra there. But that's what I mean when they say, like, show that equals that. Most of the time it's not this hard. That was pretty difficult. But that's what they mean. They mean make it, do some math, factor stuff out, make it look like that. Okay, most of the time it's more straightforward than this, but I wanted to show you a hard one. Okay, let's go to our last one right here. Now I do want to say this is kind of on top of this one. So like that's problem A, this is like problem B. So right here is like little problem B. Right? So look what it says. Find out x coordinates on the point y equals square root of x times 3 minus x squared. Notice it's the exact same problem. The tangent is horizontal. So this is the key part of it. Understand what this means is the main thing. Right? So tangent line is horizontal. So remember, if I have a tangent line that's horizontal, that means that the derivative equals 0. Right? Horizontal tangent lines, our derivatives are equal 0. So, right, this is the whole reason IB does this. It's a classic IB, right? These problems are connected. They're like, hey, here's the function, here's its derivative, show me you get that. So they want you to give you a lot of points for showing that. But if you got that wrong, if you didn't know how to do that, you can still solve this problem because it says they gave you the derivative. That's why they do it. So anytime they say they give you a show that, it's probably because they want you to use that later on. So if you don't know how to do this, you could skip all this, still get some points down here. Don't skip this, by the way. But anyway, the whole idea is solve that. So all I gotta do is set that derivative equal to 0. So 3 minus x, 3 minus 5x, all over 2 radical x equals 0. Right, and how do we solve this? Well, multiply by the reciprocal. Multiply both sides by the denominator. It goes away, because anything times 0 gets destroyed into 0. So you get 3 minus x, 3 minus 5x equals 0. Then this goes away. Split it. Then you get x equals 3, and then x at the 5, x equals 3 over 5. So that's the idea. And that's it for quotient rule.